Good morning, dear student. In today's lecture, we will discuss the important points regarding to the CHI 330 homogeneous catalysis section second, that is metathesis. So we are very much interested in the olefin metathesis. So what is this olefin metathesis? Olefins means the carbon-carbon double bond. So in metathesis reaction, the double bonds breaks. So the double bond present in alkene, which is already present in alkene, it is break, and the new fragments are rejoined. So you should remember this point. The breaks double bond breaks, and the new fragment are rejoined are rejoined. So again, the one more important points is that each new double bond is formed. Each new double bond is formed. Each new double bond is formed between two sp2 carbon, between two sp2 carbon that are not previously joined, that are not previously joined. So you should remember this point. Each new double bond is formed between two sp2 carbon that are not previously joined. For example, if you consider a general reaction, that is RCH. So right here. Okay, so you should remember this point. The double bonds is break and the new fragments are rejoined. Each new double bond is formed between two sp2 carbon that are not previously joined. For example, let us see the example of this metathesis reaction, olefin metathesis reaction, that is RCH double bond CH2. And you can say this is carbon number 1, this is carbon number 2. Again another molecule is there, CH double bond CH2. This is carbon number 1, carbon number 2. So in presence of catalyst, these two alkenes or olefins undergo metathesis reaction. So the bond, the original bond is break, and the new bond is formed between two sp2 carbon that are not previously joined. Means the new bond is formed between carbon number 2 and this carbon number 2. Similarly, the new bond is formed this carbon number 1 and this carbon number 1. Okay, so new bond is formed. So we can write here R. Okay, so it will attack here, and at the same time it will attack here. So what you get here, CH2 having, this is your CH2, this is your CH, and this is R group. So this is your intermediate, and the new bond is formed between carbon number 1 and 1 and carbon number 2 and 2. So in this case, so you can write here, this bond will be break and it will goes here. So with the formation of, so what you get here, R CH double bond CHR, and what you get here again, we get alkene CH2 double bond CH2. So this is your metathesis reaction. So you should remember. So the new bond is formed between two sp2 carbon. Sp2 carbon means carbon carbon double bond. Okay, sp2 carbon that are not previously joined. So the carbon number 1 and 1 is not previously joined, carbon number 2 and 2 is not previously joined. So the new bond is formed, and this is called as metathesis reaction. This is called as metathesis reaction. Again, if you consider the different types of this metathesis reaction, for this metathesis reaction we required a catalyst. So before discussing the catalyst, so we will discuss the types of metathesis. Olefin metathesis. Types of metathesis. The first type is simple metathesis. So already we see the example. It is an example of simple metathesis. Means the metathesis reaction involve only one kind of substrate. So the metathesis reaction which involve only one type of substrate, only one type of substrate, then it is called simple metathesis. Means both alkenes are similar, so both alkenes are same. So in this case, this is your propene, this is your propene, so both alkenes are same, then such a type of metathesis reaction, it is considered as a simple metathesis reaction. Again, in this case you should remember only one type of substrate is there, and we get both E and Z isomer, both E and Z isomer. So you should remember this 2 point. Okay, so type of metathesis, first is simple metathesis. Let us discuss the next type of metathesis, that is cross metathesis. It is cross metathesis. Cross metathesis. So what is this cross metathesis? Cross metathesis means the reaction which involve two different substrate or two different alkenes or olefins. It is called cross metathesis, which involve two different substrate, then it is called as cross metathesis reaction. For example, let us consider the example, that is CH3 CH double bond CH3, okay, and another is CH3 CH2 CH double bond CH2. So both alkenes are different, and in presence of catalyst, they will forms the product. Again, same is the case here. This is carbon number 1, this is 1, this is 2, and this is 2. So the new bond is formed between carbon number 2 and 2 and 1 and 1, and we get a product. So what you get here? We get CH3 CH3, and having this is your CH is there, this is your H is there, and this is your CH2 CH3 group is there. Again, the new bond is formed between these two carbon number 1 and carbon number 2, carbon number 1 1 and carbon number 2 2. So we get here, what do you get here? CH3 CH double bond CH CH2 CH3. Okay, we get this, and again what you get here, plus what you get here, CH3 CH double bond CH2. So this is the example of cross metathesis in which both alkenes are different. Let us discuss the next type of metathesis, that is ring closing metathesis. Next, that is ring closing metathesis. Ring closing metathesis. So in this type ring closing metathesis, we discuss the role of catalyst, because this ring closing metathesis is simply an intramolecular alkene metathesis. So you should remember this point. It is an intramolecular, within molecule, intramolecular alkene metathesis. It is intramolecular. Second, it forms an cycloalkene with less or no ring strain and a volatile alkene. For example, if you consider, this is your example, this is your alkene. In presence of catalyst, we get this new double bond is there, and plus what you get here, alkene, CH2 double bond CH2. So for this ring closing metathesis, for this ring closing metathesis reaction, we required a catalyst, that is Grubb's first generation catalyst. So we required catalyst, that is Grubb's or groups. It is called Grubb's or groups first generation catalyst. Grubb's first generation catalyst. So what is this catalyst? Let us discuss its structure for ring closing mechanism, a ring closing metathesis reaction. So this is your catalyst. This is your ruthenium is there, double bond pH is there. This is your PCY3, PCY3. This is your Cl, and this is your Cl. So if you consider what is its PCY3, it is cyclohexyl. So tricyclohexyl phosphine. It is tricyclohexyl phosphine. It is 2 electron donor. It is 2 electron donor. These chlorines are 1 electron donor. If you consider the oxidation state of ruthenium is +2. Oxidation state is +2, and it is a 16 electron species. It is an 16 electron species. So it is coordinatively unsaturated. Its oxidation state is +2, and this catalyst, that is, it is known as Grubb's first generation catalyst. It is used for metathesis reaction when the alkene is monosubstituted. When the alkene is monosubstituted and disubstituted. The alkene is monosubstituted and disubstituted. For example, if you consider this is alkene. So this carbon, if you consider this carbon having only one substitute, therefore it is considered as a monosubstituted. And if you consider the another example, so this is your disubstituted. So you should remember, whenever we consider a ring closing metathesis or metathesis reaction using Grubb's first generation catalyst, this catalyst is used for monosubstituted and disubstituted alkenes. So you should remember, whenever there is a monosubstituted or disubstituted alkene, then we can use this Grubb's first generation catalyst. Again, if you consider our example, we already discussed the example of this ring closing metathesis reaction, that is, so this is your example. So in this case, if you consider this carbon, it is monosubstituted. It is also monosubstituted in presence of Grubb's or groups first generation catalyst. We get this product. Plus alkene. So you should remember, whenever there is a ring closing metathesis, the new bond is formed. So ring is closed and the new pi bond is formed. So this is your Grubb's first generation catalyst. You should remember, this Grubb's generation catalyst, it is used when the alkenes or the olefins is monosubstituted or disubstituted. We discuss the Grubb's second generation catalyst, but it is used for tri or tetra substituted alkenes. So in this lecture, we are very much interested up to Grubb's first generation catalyst. So at least you should remember this role of Grubb's first generation catalyst. It is used when the alkene is monosubstituted or disubstituted. So let us discuss the mechanism of this Grubb's first generation catalyst. So if you consider the mechanism, let us consider this is your alkene. This is your N tosylate is there. So we take an organic example, organic chemistry example. So this is your alkene. this is your monosubstituted alkene. So if you consider this carbon and this carbon, it is a monosubstituted. So we can use Gruff's first generation catalyst for this ring closing metathesis reaction. Again, in this you can write here, this is your N TS double bond is there. Okay, so the first step of this Gruff's first generation catalyst is 2 plus 2 cycloaddition reaction. 2 plus 2 cycloaddition reaction. So you are very much familiar with this 2 plus 2 cycloaddition reaction. So the catalyst, that is your ruthenium catalyst, it will interact. For example, in this case here double bond. Okay, this is your pH. Okay, this is your ruthenium, and this PCY3 group we are denoted by simple R group. So there is a 4 substituent out of that 2 are chlorines and 2 are tricyclohexyl phosphine, which is denoted by symbol R. So in this case we consider PCY3 as your R. Okay, so this is your Gruff's catalyst. It will shows 2 plus 2 cycloaddition reaction with one of the alkene. So in this case it will attack here, at the same time it will attack here. So 2 plus 2 cycloaddition reaction. So in this case, what is the product? What you get here? This is your ruthenium is there, this is your pH is there, and the 4 substituent 2 chlorine and 2 R group means PCI3 group. Okay, and then the carbon is there, and this is your group, that is N TS, and the remaining is double. Okay, so we know that the new bond is formed between this carbon number 1 and carbon number 1 and carbon number 2, and second is the metal atom. In this case there is a metal atom, it is not carbon atom. So what you get here, this is your intramolecular. Okay, if you consider the first step is 2 plus 2 cycloaddition, and then there is a intramolecular metathesis reaction, means the new bond is formed. So in this case this bond is shift here and this bond is shift here, this bond is shift here, the new bond is formed. So what you get, it is an intramolecular, it is an intermolecular, not intramolecular, because you should remember this one. I will make a mistake. It is an intermolecular because one is your alkene and second is your Gruff's catalyst. So they are both are different. So it is intermolecular. Intermolecular metathesis reaction, and the new bond is formed between this carbon number 1 and carbon number 2 and the metal atom. So what you get here, we get here pH double bond CH2, pH double bond CH2 plus what you get here, the new bond is formed between this ruthenium, which having a 4 substituent, and the remaining part is same, that is your N TS is there, and the remaining is double bond is there. So we get this alkene, and in the next step again there is a 2 plus 2 intermolecular cycloaddition reaction. So the first is intermolecular. So if you consider the first is intermolecular cycloaddition reaction and the second is intramolecular cycloaddition reaction. You should remember, in the first step this is intermolecular, 2 different molecule, but in the next step this molecule, it will shows intramolecular metathesis reaction. It will shows intramolecular metathesis reaction. It will shows intramolecular metathesis reaction. This molecule shows intramolecular metathesis reaction. Let us discuss the mechanism. That is what you get here. We get this ruthenium having 4 substituent, double bond is there. Again it is attached to N TS, which is having a carbon and having a double bond. So we can write this as we can write this as in the form like this. This is your N TS. Again, this is your alkene is there, double bond is there, and this is your ruthenium is there, a double bond Ru is there, and it having a 4 substituent, 2 chlorine and 2 PCY3. And this molecule and this molecule is same, but it shows intramolecular within the molecule. Okay, the first step is intermolecular 2 plus 2, the second step is intramolecular 2 plus 2 cycloaddition. It will shows again 2 plus 2 cycloaddition reaction. So it will goes here, it will goes here, and what you get here in the next step, what is in presence of what you get here, it is intramolecular, and what you get here, the bond is formed. So we get this is your ruthenium is there, it having 4 different substituent, then this is your carbon CS2, okay, and then this is your NTS is there, NTS is there, and again we know that the new bond is formed between 2 sp2 carbon which is not previously joined. So the new bond is formed. So in this case, this will goes here and this will goes here, and what you get here, we get a product in which NTS is there and there is a double bond is there. So we get a ring closing, and the remaining is what you get, the remaining is what, the ruthenium, it having 4 substituent, and there is a double bond CS2, and there is a double bond CS2 is there, double bond CS2 is there. Okay, so this is your intramolecular 2 plus 2 cycloaddition reaction, intramolecular 2 plus 2 cycloaddition reaction, and this is the example of ring closing metathesis reaction. So you should always remember the point, whenever the alkene is mono or disubstituted, we use Grubb's first generation catalyst. The first step of the mechanism is intermolecular plus 2 plus 2 cycloaddition, and in the second step there is a intramolecular 2 plus 2 cycloaddition to give a ring closing metathesis reaction. In the next lecture, we will discuss the ring opening metathesis reaction and the remaining catalyst used for metathesis reaction. Thank you.